Let's divide in scientific notation. Here's our example expression. We have 9 times 10 to the 14th power divided by 3 times 10 to the 10th power. And if you think about what these actually mean, if we were to write these in standard form, you'd have 9 times 10 to the 14th power in the numerator of your fraction. That's 9 with 14 zeros because we're moving the decimal to the right 14 times. And then in the denominator of our fraction, the standard form would be 3 and then 10 zeros because we're moving the decimal to the right 10 times. 3 times 10th to the 10th power. So we use scientific notation to make dividing these two really big numbers a little bit easier. We don't have to worry about the zeros and making a mistake with all of those. So let's divide these two numbers in scientific notation. To do this, we're going to break it into a couple steps. It's like dividing like terms because we're looking for the same base. If we start with everything before the multiplication sign, the 9 and the 3 in this case, let's just divide them like normal. 9 divided by 3, that would give us 3. Then we can bring down our multiplication sign, and then we're left with just our bases of 10. 10 to the 14th power divided by 10 to the 10th power. So I can take my 14 and my 10 in my exponent, and I can subtract them because that's quotient rule for exponents, where I subtract the exponent since I'm dividing by the same base. And that would give me 10 to the 14th minus 10 power. From here, I've already divided my expression, and all I have to do is simplify, so I can write this in scientific notation form, and I get 3 times 10 to the 4th power. That's it. Nice and simple there, but sometimes the question asks us to rewrite our answer in standard form, which we already know how to do, so we take it that extra step, write this in standard form by moving the decimal to the right 4 times, and we get 30,000 as our answer. And that's it. That's how we can divide in scientific notation.